see this? A programmer made that. But how? If we go to inspect, you'll see this right panel. This is a tag. It's not important right now what a tag is, but this is an image tag, which means it's an image. That's it. This class attribute doesn't matter right now, so we're gonna skip it. And this means source, which is where the image comes from. It's the image's path. This alt attribute means alternative text. If the image doesn't load, this text will appear on the screen instead. Watch, I'll change the source. See? Now, when you see that again, you'll know that the image isn't available or the programmer didn't specify the path correctly. This is a title attribute, and it's the tooltip that appears when you hover your cursor over the image. That's it. This is the image's width. Pretty obvious what that is. And this is the tags ID. We'll talk more about IDs in future videos, but for now, it's important to understand that all of this could be made by one person, thanks to programming and coding. And that person, yes, could be you. Have you ever wondered how one skill can be used to build video games, train artificial intelligence, discover new medicines, defend companies from hackers, and even help spacecraft explore space? It sounds impossible, but all of those things have one thing in common: programming. And by the end of this video, you're going to understand what programming actually is, why it powers almost everything around you. Let's remove all the mystery. Programming is simply writing instructions for a computer. That's it. A program is a set of instructions that tells a computer exactly what to do. Think of a recipe. Imagine I tell you, crack 2 eggs, mix them, put them in a pan, cook for 3 minutes. Those instructions produce an omelette. Now imagine giving instructions to a computer. Open this file, read the data, calculate the average, show the result. Different instructions,
same idea.
Programming is creating those instructions. But here's the weird part. Computers are simultaneously the smartest and dumbest thing you'll ever work with. They can perform billions of calculations every second, but they can't understand what you meant, only what you wrote. If you tell a human, bring me the blue book, they can figure it out. If you tell a computer, bring me the blue book, the computer responds, what the fuck is a book? Programming is learning how to communicate with a machine that follows instructions perfectly, but understands absolutely nothing beyond those instructions. But there is one problem. Computers don't actually understand English. They understand machine code, which looks something like this. That's why programming languages exist. A programming language is a way for humans to write instructions that computers can understand. Different languages have different styles, strengths, and purposes. Some popular examples are Python, JavaScript, Java, C++, C#. They're all used to solve problems, just in different ways. Think of them like spoken languages. English, Spanish, and French can all communicate the same idea, but they use different words and grammar. Programming languages work similarly. And one of the reasons Python became so popular is that it looks surprisingly close to plain English, making it easier to read and learn than many other languages. Programming is not really about computers, it's about solving problems. The computer is just a tool. A hammer isn't valuable because it's a hammer. It's valuable because it helps build things. Programming is the same. The question isn't, what can Python or Java do? The better question is, what problem do you want to solve? And the answer determines how you will use programming. Let's look at some real examples. Imagine you work in an office. Every morning you receive 500 emails. You have to download attachments, rename files, organize folders, and send reports every single day. Sounds fun, right? Ha! Not unless your dream job is becoming a professional button clicker. This is where automation comes in. Automation means teaching a computer to perform repetitive tasks for you. Instead of doing something 500 times, you write a program once. The computer does it forever. For example, renaming thousands of files, sending scheduled emails, downloading data automatically. People have saved hundreds of hours by automating tasks that previously consumed entire workdays. But what if we could automate thinking, not just repetitive work? What if a computer could recognize faces, understand speech, generate images, write text? That's where things get really interesting and at the same time like Artificial intelligence is one of the most exciting applications of programming. Instead of explicitly telling every rule to a computer, we allow it to learn patterns from data. What kind of data, you might ask? Well, what about all the projects that I have on GitHub? Yes. What about everything I've learned in the last 10 years? Yes. Let AI handle that. Why not? Who said I wanted to work? Now seriously, it's a tough dilemma and it's complicated for everyone because you don't want to use it, but if others do, you'll be left behind. And yes, but if you want to know, think about teaching a child to recognize cats. You don't explain every possible cat shape, you simply show many examples. Eventually the child learns. AI systems work similarly. You feed them massive amounts of data, the program finds patterns, then it makes predictions. Examples include chatbots, recommendation systems, image generation, language translation, etc. When a streaming service recommends a movie you actually enjoy, that's programming combined with AI. When your phone recognizes your face, same thing. But wait! How does an AI learn? Where does all the information come from? Besides every tutorial online? Just slow down. Yeah, sorry. The answer leads us directly into another field. Imagine someone gives you a spreadsheet containing 40 million rows of information. Data science is the process of collecting, cleaning, analyzing, and extracting useful insights from data. Think of it as detective work. The clues are hidden inside numbers. Programming helps reveal them. For example, a company might ask, why are customers leaving? The answer may be hidden inside years of sales data. Python, for example, helps analysts process enormous datasets that would take humans years to examine manually. For example, sales. The most important thing on a company. You have this data set, which is just a bunch of data. You can see here the product ID, the sales amount, the quantity. Then you could make graphics with this by writing code. You could export what you have and use it on a different software, etc. But not everyone uses programming to find information. Some people use it to protect information, and sometimes they are fighting people who are trying to steal it. Imagine your house had millions of doors. Every website, every computer, every phone, server, network connection. Now imagine criminals trying every door handle they can find. That's cybersecurity. Cybersecurity involves protecting systems from unauthorized access, attacks, and vulnerabilities. Programmers create tools that detect suspicious activity, analyze malware, test security weaknesses, protect sensitive information, etc. Ethical hackers use programming to find weaknesses before criminals do. Thinking of it like hiring someone to try breaking into your house so you can fix the locks before an actual thief arrives. Speaking of simulations, what if instead of protecting systems, you wanted to create entire worlds? Worlds with physics, characters, enemies, explosions. And eventually, this. Every video game is ultimately a collection of instructions. When you press a button, the game responds. Programming controls everything. Even simple games contain thousands of decisions happening every second. For example, player movement, collision detection, enemy behavior, physics calculations, inventory systems, etc. Many programmers first fell in love with coding because they wanted to create games. And if that's not impressive enough, let's leave Earth entirely. Programming plays a massive role in space exploration. Space missions generate enormous amounts of data. Satellites collect images. Telescopes observe distant galaxies. All of that information must be processed, analyzed, stored, visualized. Programming helps scientists understand what they are seeing. Now, think about it. The same language you might use to automate your homework folder can also help analyze information coming from space. That's awesome! So what is programming really? After all these examples, you might think programming is about websites, games, AI. It's not. Programming is about solving problems. Data science solves information problems. Game development solves, well, life, basically. The tool is the same, only the problem changes. Right now, you don't need to understand cybersecurity. You don't need to understand data science. You only need to learn one thing: how to give a computer instructions. That's where every programmer starts, every game developer, every cybersecurity expert.
One instruction at a time.
And in the next video, you're going to start learning that stuff. So check out my channel for more information, and see you next time.